Now, what do you know about an isosceles triangle? Two sides are the same. So if two sides are the same, how long is this side going to be? 8 meters. What do you also know about an isosceles triangle? These two angles are going to be the same. Do we know for sure, are all isosceles triangles right-angled triangles? No. So we can't say that that top angle is 90 degrees. It might be 89. We can't say for sure, looking at this diagram, that it's exactly 90 degrees. So we can't use SOHCAHTOA on this triangle right now because we don't know if we have a 90-degree angle. However, we can make a 90-degree angle by going from the top here and drawing a line straight down. That will make this angle 90 and this angle 90. If I do that, using logic, can you see that this angle here has to be the same as this angle there? Because if the bottom two green angles are the same, and this one plus this one plus this one have to add up to 180, then those angles, the blue ones, have to be the same. And since we have two sides that are the same, that makes these two little triangles exactly the same. Do you know what word they use in geometry when two shapes are the same? Symmetrical. Symmetrical is close. Symmetrical is when they're symmetrical because they flip over and you can see the same shape when we flip over. It starts with C. Congruent. Don't you think they should just use the same? Like, they're the same. Why do they have to come up with a long word that starts with the letter C? Jeepers. They want to be special. Yeah. Okay, so they're congruent. And because they're congruent, what does this height split the bottom into? 6 and 6. Even the height of a triangle has a special name. The height of a triangle, it's called the altitude of a triangle. Okay? And because this altitude of this triangle goes to the midpoint, it's also called the median of the triangle. There's a median and an altitude in this triangle. It's the same line. I don't know. Lots of fancy words. So now I'm going to draw this triangle here. Okay? I'm going to draw this triangle there. That's a right-angled triangle. I'm going to give these sides names A, B, these points A, B, and C. Because we have to solve this triangle, so we have to find angle A, angle B, angle C. And we've already found all three sides. So which angle do you want to find first? Angle A. Angle A in that red, with the red triangle I've drawn, angle A is the only one you can find directly first, right? So if I'm finding angle A, where's the hypotenuse? The 8 is the hypotenuse. So what can I use? SOHCAHTOA, go to your definitions. Sine, cos, or tan. Going to have to be cos. Because I have an adjacent side I know and a hypotenuse that I know. So then I would write cos of A, adjacent is 6 over hypotenuse 8. And so take cos inverse of both sides, because that's how you find an angle. That gets angle A by itself. Cos inverse of 6 divided by 8, 41.4. So angle A equals 41.4 degrees. We've solved for one of our angles. So I put a circle around it because that's one of the things we needed to solve for. This 8 was another thing we needed to solve for, so I'll put a circle around that. What would you like to find next, angle B or angle C? We already have angle C. What is angle C? 41.4 because it's equal to angle A. Put a circle around that one. How are we going to find angle B? So if we started with angle B, started with 180, and you said subtract the two of them, you get, what's left? 97.2. That's angle B. Put a circle around that. And we found all three. To find which one? Well, angle B, if we do a squared plus b squared equals c squared, that's dealing with sides, right? So this is a little b, not the angle, right? So we can't use that for the angles because the angles add up to 180, but the a squared plus b squared equals c squared is for sides. And so if we needed this height, then a squared plus b squared equals c squared would work well. So there's our three angles, and we found the other side. So we have solved this completely. Woohoo!